Welcome to the Doppler Effect Show, written by Dealo. Today we'll learn about the Doppler effect, but first let's talk about the background of frequency and the speed of sound waves. Frequency, the number of oscillations per unit of time. The symbol for speed is V. Speed is measured in meters per second. The symbol for frequency is F, and is measured in hertz. FD equals frequency of the detector. Who hears it? Fs equals frequency of the source. Who makes the noise? V equals velocity of the wave. Vd equals velocity of the detector. Vs equals velocity of the source. Here's the formula. Fd equals Fs multiplied by V plus or minus Vd over V plus or minus Vs. Here's our problem. A boat is moving towards a stationary submarine at 20.5 meters per second. The submarine exits a 4.7 kilohertz wave. The speed of sound wave is 1,582 meters per second in water. What frequency would a boat detect? This is how it would look. The Fs, or the frequency of the source, is 4,700 hertz. The velocity of the water is 1,582 meters per second. Velocity of the detector is 20.5 meters per second. Vs equals 0 meters per second. These are stated in the problem. So these are our givens. Once again, here's the formula. Fd equals Fs multiplied by V plus or minus Vd over V plus or minus Vs. Then you plug it in. Fd equals 4,700 times 1,582 plus 20 plus 5 over 1,582 plus 0. You use the plus because the detector is moving towards the source. It doesn't matter what you use at the bottom because it's not moving. You add the 1,582 and 20.5, then divide by 1,582. After you do that, you will get 1.01. Multiplied by 1.01 by 4,700. That's how you get your final answer. FD equals 4,760.912 hertz. If the boat is going towards the submarine at 20.5 meters per second and the submarine exits 4,700 hertz and the speed of sound wave is 1,582, then the boat will receive 4,760.91 hertz. Thank you.